So I'm going to start with a question. Raise your hand if you've taken individual action to mitigate your carbon emissions. I thought so. I thought most of the audience would, which is great. The reality, however, is that individual action is limited by the system in which we operate. I have an electrified house, but that does not mean I have a net zero emission house because I'm connected to the grid. So the system in which we live constrains the effectiveness of our individual choices, which means we're going to need systemic change. My name is Paulina Jaramillo. I'm a professor in the Department of Engineering and Public Policy here at CMU, and I'm the co-director of the Open Energy Outlook initiative, which I'll be talking about today. In 2022, the IPCC published the sixth assessment report on climate change. This is a main figure from the Working Three report, which shows the gap between our commitments to climate mitigation and the emission trajectories that we need to pursue to reach the 1.5 to 2 degree climate temperature change limit. So in this figure, the red represents the trajectory of emissions based on what we've committed to date, and the purple, green, and blue show the trajectories that are needed to reach the 1.5 to 2 degree target with different levels of overshoot. So this figure highlights that to limit the temperature change to 1.5 to 2 degrees above pre-industrial level, we will need to have deep, rapid, and sustained reductions of greenhouse gas emissions like CO2. What does that mean for the US? So the US is the second largest source of emissions. In the US, emissions were 6.335 gigatons of CO2 in 2021. I realize this figure has the problem that Vivian highlighted, where it has electric power separate. The way I wanted to highlight the figure is commercial, residential, industry, electric power, and transportation are all related to energy use activities. There are some small emissions in industry that are not energy driven, but for the most part, more than 80% of emissions in the US are from energy related activities. Some of it is in power generation, and some of it is actually directly in buildings, but they're all connected. So at the Open Energy Outlook initiative, we are developing tools and doing studies to evaluate what are the transition pathways for the US energy system that are consistent with reaching our net zero targets that are needed for the Paris Agreement. So we have developed a large-scale energy system model and a database of the energy system where we have parameterized 3,000 distinct service demands and 80,000 conversion processes. This model includes choice of different end-use technologies in the building sector, as well as the supply of different energy services. The model currently is open source, and the database is also open source, so it can be accessed through our GitHub and our website. So at this Energy Week, we're launching our second report. This is an image. I have a physical version. It was being distributed in the registration table. I'm not actually sure if they ran out or not. They ran out, maybe. But if they didn't, you can get it, and it will be posted online. This report follows a report we published in 2022, and this specific report focuses on the implications of the Inflation Reduction Act and how the Inflation Reduction Act affects the transition to net zero. So I'm going to present a couple of figures with some of the results, starting with the emission trajectory under the Inflation Reduction Act. Let me see if this is working. So this is an emission trajectory of annual emissions by sector. And so these are direct emissions. So electricity is shown here as its own sector, and what we have as commercial and residential are direct emissions from buildings. The Inflation Reduction Act, the provisions of the Inflation Reduction Act expire by 2035. And so what the figure is showing is that we see a reduction in total emissions by 2035, but in the absence of additional policy, emissions would bounce back and by 2050 reach similar levels to 2025. To get to net zero, we have to maintain a downward slope. And this is the substantial reduction. So what we see here is basically after with the Inflation Reduction Act, decarbonizing the electric power sector and then decreasing emissions in all the other sectors. One important finding here in this figure is that we have what you would refer as negative emissions, which represent carbon dioxide removal. And so these are technologies that actually remove CO2 that is already in the atmosphere. The model currently represents two carbon dioxide removal technologies. One is bioenergy with carbon capture and sequestration, and the other one is direct air capture. And this finding about the likely need for carbon dioxide removal to mitigate residual emissions from hard to decarbonize sectors is consistent with the findings of the IPCC in the climate assessment report. This is what we see for energy in terms of energy, primary energy. And I will point out that this figure, it's called primary energy, but it also includes renewables, which are not really a primary energy. We're accounting for the energy of electricity generated with renewables, not the primary energy in the renewables. So for fossil fuels, it is primary energy, and then we added the energy produced from renewables. And so this is the scenario with the Inflation Reduction Act. And what we see is by 2035, just a reminder, that's when the Inflation Reduction Act provisions are expiring. And so in this scenario, we see reductions in petroleum use, and they continue even after the Inflation Reduction Act. This is a lot related to decreasing cost of vehicle electrification. But what's interesting is that after the Inflation Reduction Act, the share of energy from renewables remains pretty constant, and we start seeing an increase in natural gas use. Again, this is the scenario that does not reach net zero, and actually emissions without additional policy constraints reach the same levels by 2050 as what we started from. In the scenario with a net zero constraint, we see a lot more renewables. There is some changes. There is some increase in natural gas in the last period because of the decommissioning of nuclear power plants. And we don't fully phase out natural gas plants. That's why we saw the need for carbon dioxide removal. And these natural gas is used in what is the hard to decarbonize sectors. One thing to note is because the model is endogenizing all of the decisions in the energy system, it has to realize you can't just infinitely build the electricity system. So even if you could use hydrogen for some of the end uses, you have to balance the fact that you have to build the electricity system to produce that hydrogen and all of the other electricity that we'll need. So there are some constraints here that we can only observe when we have a system-wide model that looks at interdependencies of systems and end uses. But ultimately, what we find in the report, the main conclusion is that the Inflation Reduction Act, which is a groundbreaking legislation in the US, can lead to an emission reduction of roughly 40% by the middle of the 2030s, but additional policy support will be needed to reach net zero by 2050. I should mention that the Open Energy Outlook initiative is working on continuous updates of the database to account for changes in technology and the availability of new technologies, changes in cost. And we're using the model to do a lot of other analyses of looking at more detail to individual sectors. We looked at the hydrogen provisions in the IRA and submitted comments to the Treasury Department on it. And you can find all of that information in our website, which I think it's easy to remember, openenergyoutlook.org. That will take you to a CMU website, but it's easier to remember the openenergyoutlook.org website.